Next line drawing algorithm is Bresenham's line generation. Now there are two disadvantages of DD algorithm. The primary disadvantage is a rounding off operation. A rounding off operation is always a non-preferable approach. Why non-preferable? Because rounding off involves a heavy computation. So it is always recommended to avoid the rounding off operations, because rounding off will not give you the exact value, one thing. Another is it is an extra computation. You are going to involve your CPU for the extra computation part. So you need to avoid that. So one problem is rounding off operation for DDA. Second is DDA will generate a staircase effect. Staircase effect means when you will draw the line may not be straight enough. The line will have repetition in the coordinates of x or repetitions in the coordinate of y depending upon the number of steps. So there may be repetition of the coordinates. So whenever we are repeating some coordinate, if we are repeating x and you are changing y, so obviously it will become a staircase effect, and vice versa. So in both the cases, whether your steps is equal to dx or your steps is equal to dy, so whichever is having the lower value, whichever coordinate is having the lower value of change, the line will generate the staircase effect on that particular coordinate. So here you can see, because it is 15, it is 10, so there will be actually 5 repetitions. Then only you can make this 10 to 15. There will be 5 repetitions, and those 5 repetitions will make this dx steps or this x coordinate equivalent to dy steps. So that is also a problem. So these two issues are there with DDA. So one major issue of rounding off is completely resolved in the Bresenham line generation algorithm, and staircase effect is also reduced. So in Bresenham line generation algorithm, you will input the two endpoints of the line, and the left endpoint you will store it in x0 and y0. Remember, this algorithm is for the lines having slope less than 1. So when we say slope less than 1, that means x2 minus x1 is greater than y2 minus y1. So now what is slope? We all know slope is y2 minus y1 divided by x2 minus x1. So if change in x is greater than change in y, then this is these 5 steps, this is the algorithm. Otherwise, I will tell you by this line when we reach here. So what to do? So for lines having slope less than 1, first step is input the two endpoints and store the left endpoint in x0, y0. Now plot the point x0, y0. Now plot it. After that, calculate dx, dy, 2dy minus 2dx. So and get the first value of decision parameters. These are constant, you want to calculate it or not, doesn't matter. But the first value of decision parameter is important here. This algorithm is based upon the decision parameter. So that decision parameter will decide what we have to do next in the algorithm. It will decide which will be the next point to be plotted. That will depend upon the decision parameter. So how we will calculate the decision parameter? We will calculate it like here, like P naught. The first value is 2 dy minus dx. That is the first value. Now after calculating the decision parameter, now step 4 is important. It will actually decide what point has to be plotted. So at each xk along the line, starting at k is equal to 0. So for every x position, so we will perform the following test. What is the test? If pk is less than 0, if the value of this decision parameter that you have calculated here, if its value is less than 0, then the next point to plot is xk plus 1 and yk, means the value of x is being increased by 1 and yk will remain same. So we will increase the value of x and we will keep the value of y. And the new value of decision parameter is pk plus 2 dy. So actual the current value that was this initial decision parameter, so that value plus 2 dy, so that is the new value of p. So this was the condition for if pk is less than 0. If it is equal to 0 or greater than 0, so that is otherwise next point to be plotted is xk plus 1 and yk plus 1. Now see, x is being increased whether you have the value of p less than 0 or greater than 0. X will be increased. Y will be decided, the change in y will be decided by this decision parameter. So let me repeat again, like this is for slope less than 1, and when slope less than 1, that means change in x is greater than change in y. So that's what we are doing here, because change in x is greater than change in y, so x is being increased every time. Y will be increased or not, that will be decided on the basis of decision parameter. So in otherwise condition, so next point to be plotted is xk plus 1 and yk plus 1, and the new value of decision parameter, that is pk plus 1 is equal to pk plus 2 dy, similar minus 2 dx. Here we have minus 2 dx. Now repeat step number 4. Repeat this step for dx minus 1 times. So dx minus 1 time. So whatever is the change in x, so minus 1 time. Now why minus 1 time? Because you have already plotted the first pixel here. So change in x means total number of pixels to be plotted. So you have already plotted 1 pixel. So that's why you will repeat the step number 4 dx minus 1 time, and it will complete the drawing of your line. So this was for slope less than 1, and for m is greater than 1. If slope is greater than 1, then find out whether you need to increment x while incrementing y each time. Now if m is greater than 1, when it will be greater than 1? When change in y is greater than change in x. And when change in y is greater than change in x, that means you will have to increment y each time. But you will have to decide whether you need to increment x or not. So that is what is for m greater than 1. So otherwise, if you are having a line less than with slope less than 1, so this will be the algorithm for that. So you will have to take care. So whether you are being asked for less than slope less than 1 or greater than 1, you have to attempt your question accordingly. And if you are getting in general, then you will have to specify the algorithm that we are writing, like this algorithm is for slope less than 1, or this algorithm is for slope greater than 1. You will have to take care about that.